Wave 40 deals with drawing electron dot diagrams. And you want to remember that in order to draw dot diagrams, you must first look at the valence electron number for every atom in question. That can be found by looking at the last digit of the electron configuration on the periodic table. You want to draw it so that each atom features a stable octet, meaning every one of that outer shells features 8 valence electrons. So when you've drawn your structures correctly, you'll have exactly 8 dots around the major atom, with the exception of hydrogen, which only needs 2. So let's try some problems before going straight to this. Draw a Lewis electron dot diagram for a molecule of hydrogen fluoride. I'll go over this example first before going over the others. If you look at the last digit of fluorine and hydrogen, fluorine has 7 valence electrons and hydrogen has 1. The only way to draw it such that both our atoms are happy is to draw a covalent compound where those electrons are being shared between hydrogen and fluorine. Notice that this diagram features those 7 dots around fluorine, and to show the electrons coming from hydrogen, they use an X. So those electrons is one electron from fluorine and 1 electron from hydrogens are being shared, so that fluorine is happy with that octet and hydrogen also has a filled outer shell of 2. Alternatively, you can draw a pair of electrons using a single line, and that indicates the bond, a covalent bond between hydrogen and fluorine. Note that here that because that single bond represents 2 electrons, when I talk about fluorine's electrons, it already has 8 valence electrons, and this bond contains the 2 electrons for hydrogen. You rarely see this diagram, but you could also use this. Instead of drawing the dots, they simply use a dash to indicate 2 electrons. So here, fluorine is drawn with 8 valence electrons, and hydrogen has that too. Let's try some others. Which Lewis electron dot diagram represents the bonding in potassium iodide? You should note that potassium and iodide is a metal-nonmetal combination. So we're looking for ionic bonds. And you know that in ionic bonds, the metal donates its electrons to the nonmetal. So potassium gives its electrons away to iodine so that iodine can achieve a stable valence electron configuration. How do we represent that? We use brackets. So the one that correctly shows the correct configuration of potassium iodide is choice 1. Notice that potassium, which had 1 dot initially around it, gave its electron to iodine, which had 7 electrons initially. Potassium will become a positively charged ion, and iodine will become negative because it gained that extra electron. And notice that we draw brackets around the ions to indicate that that is a charged atom. Next problem. The equation below represents a chemical reaction at 1 atmosphere and 298 Kelvin. 2 H2 gas molecules plus O2 gas molecule yields 2 water gas molecules. In the space below, draw a Lewis electron dot diagram for water molecule. If you drew any of the following, you got it correct. Note that oxygen has 6 valence electrons, so they're represented by these 6 black dots, and hydrogen has 1. The only way for hydrogen and oxygen to achieve a stable electron configuration is for them to share valence electrons. Note that H and O are both nonmetals, so it's going to feature a covalently bound or molecular compound where electrons are being shared as opposed to being transferred. So I could simply draw H, 2 H's around O, and notice that oxygen has 8 valence electrons. 2 of those electrons come from hydrogen sharing with it. Alternatively, I could indicate those coming from oxygen with black dots and those coming from hydrogen with open dots. And remember, I could also draw a pair of electrons with a single line indicated by these dashes. So here we have H single bonded to O, single bonded to H, and we have those two extra valence electrons on oxygen. Note that oxygen has 8 valence electrons, and each hydrogen molecule has 2 of which are being shared between the atoms. Alternatively, and again, this is the rare form, is you could have drawn O with 2 H's connected to it by connected with single bonds and a line above the oxygen to represent a pair of electrons. So each one of these lines represents a pair of electrons. The most common answer you'll see is something that looks like this: oxygen with 8 valence electrons and hydrogen with 2. Draw a Lewis electron dot diagram for a chloride ion. This is asking for electron dot diagram for chloride. So if you drew any of the following, this would be correct. Note that because this is an ion, it's charged, and therefore you require brackets. Chlorine is negative, which means that it has an extra electron present in order to achieve that stable electron configuration of 8 dots around it. So we could have drawn chloride with 8 dots around it with a negative charge, or you could simply draw chlorine with 7 valence electrons initially and an extra dot to indicate that chloride has an extra electron. And again, the charge is shown at the top right corner. Or you could simply draw chlorine with 8 valence electrons represented by these black dots and that -1 charge. You have to put the charge present on that atom in order to get full credit for this answer. Lewis electron dot diagram for 3 substances are shown below. Draw a Lewis electron dot diagram for a molecule of Br2. So this problem is giving you a hint about what your answer should look like, and it's asking you to draw an electron dot diagram for Br2. When you look up bromine on the periodic table, you'll find that it has 7 valence electrons, and in order for each atom to be happy, they require 8. And because we have 2 nonmetals bound to each other, it's going to be a covalent bond where electrons are being shared, not ionic, where you have charged ions. So you could simply draw a pair of electrons being shared between the 2 bromine atoms, and each of these already has 8 valence electrons. 6 dots and 2 shared. So this bromine has 8 valence electrons, as does this bromine. Alternatively, you could draw the electrons separate, so we could distinguish the 2 electrons from the 2 atoms. Here the black dots come from this bromine and the X's come from this bromine. And notice that the pair of electrons being shared between the 2 atoms is represented by this X dot configuration. Which Lewis electron dot diagram represents a nitrogen atom in the ground state? Notice that the electron configuration of nitrogen has 5 as its last digit, so we need to draw 5 dots around nitrogen. So the correct answer has to be choice 3. Which Lewis electron dot diagram represents calcium oxide? Because calcium oxide is a metal combined with a nonmetal, you should note that this is an ionic compound. So any answer that does not show brackets or charged particles has to be incorrect. So we can eliminate answer choice 1 and 2. So it's between 3 and 4. But you should note that calcium is a metal and tends to lose electrons to the nonmetal in order to achieve stability. So calcium has a valence number of 2, oxygen has 6. In order for each atom to be happy, calcium can lose those 2 electrons, give it to oxygen, so that oxygen achieves that stable electron configuration of 8. Oxygen now has that octet. When calcium does that, it'll become positively charged. It lost 2 negative electrons and is therefore positive 2. Oxygen gained 2 electrons and is therefore negative 2. Because they're oppositely charged particles, they're going to attract one another in an ionic compound. To indicate that oxygen has the electrons from oxygen, we indicate using them black dots, and we use X for the electrons that came from calcium. Alternatively, you could just simply draw 8 black dots around oxygen. So answer choice 4 is correct. So when it comes to electron dot diagrams, look up the valence electron number from the electron configuration of the atoms in question and combine them so that each atom has a stable electron configuration. Please note that when you're dealing with covalent compounds, you're going to be sharing electrons. When you're dealing with ionic compounds, you're going to be transferring electrons, and you'll have charged particles like this example here. Hopefully this was helpful, and thank you for watching.